Hello. Hey, everyone. I'm Amy Collier, Senior Cloud Advocate at Microsoft. And with me is the infamous.
Hello, hi Amy. Yeah, Thomas here. Nice to be online and live with you now in this Learn Live session today. So super excited. Thank you, Amy.
Yes, it's going to be great. We're going to go over configuring virtual machine availability, and you can follow along just scanning that nifty QR code or going to https://learnlive-2023-0406A. Yes, and don't steal any Tim Tams.
Don't have to worry. I have enough here. Our good old teammates from Canada as well as from Australia, they did send over some good stuff. So super excited again. As Amy said, please also join us. Like you can do that Learn module together with us. You can also obviously follow us right now doing this, and we do it together. Or you can also do that Learn module later on by yourself. And I promise you that will make a lot of sense because there's a lot of stuff in this Learn module to learn about. And it makes sense to probably also run through some of the labs which are part of this Learn module. So that makes a lot of sense.
Yep. And it's already part of the AZ-104 path too. So as part of being a series, it's also, if you're studying for the AZ-104, this will be helpful.
Absolutely. Sorry that you bring this up. This is actually very, very good.
Sure.
Yeah, it's a perfect mention. So if you want to be Azure certified and you're looking at become an Azure certified administrator, which is, as you mentioned, the AC-104 exam, then this Learn module is really part of that and will help you to cover the topic around virtual machine availability. So definitely check this out. And if you haven't heard about Azure certifications, also make sure you check these out, because if you want to boost your career a little bit or just dive into and learn more, certifications are a great way of doing that.
Yes. And I'd like to welcome our moderator, Vasilis, at SQL Tattoo. It's a pretty cool Twitter handle. So he'll be answering all your questions and any Tim Tam jokes as well.
Yep, absolutely. That's another great point. Sorry to jump in. Absolutely. Like, feel free to ask your questions, right? You have like the possibility to comment on different platforms wherever you're watching. Please feel free to ask your questions. Sometimes we will ask them directly in this show, but sometimes also, as you mentioned, our moderator will be super happy to help you out if you have any questions.
Great. Yeah, make sure let's keep it interactive. We don't want to just keep talking at you. We like to interact and tease Thomas. So what we're going to learn, what's your favorite Tim Tam flavor? That's so funny. Mine is, I like the chocolate caramel, actually, when Oren brought them over. So we'll make sure they're in availability sets. We're going to implement availability sets and availability zones, implement update and fault domains, which are really important, implementing Azure virtual machine skill sets, and then auto-scaling your virtual machines.
Yeah, lots of interesting stuff here. I mean, I think availability in general is going to be a very important topic if you put your workloads, not just for in the cloud, obviously, you would have done that on premises as well, right? You would think, okay, what do I need? What type of availability do I need? Do I need a cluster with different servers, or do I need to have like even different data center locations? So we will talk about basically these kinds of things, but for Azure. And so, yeah, super excited.
Right. And availability sets, which we're going to get into, it's like a nice, easy way to start creating some redundancy. So just like on premises, you have things that, okay, we're going over the skills measure. So as we mentioned, the exam 104, you can, this covers a portion of it. Sorry for that. But yeah, you need to plan for maintenance and downtime, whether it's scheduled or unexpected. In Azure, we do have like a pre-planned maintenance window, so you won't be impacted. And then there's also an unplanned outage where you might notice some reduction in your application, but it'll be up, or unexpected downtime where we initially live migrate to a healthy physical host.
Yeah.
And so
absolutely great point. By the way, do you want to open up the web page, the Learn module on, like, so people see how that actually, like, if you've never done the Learn module, this will be how it looks like.
Actually, I'll bring up the So we're on the create availability sets. And what you want to think about is identical functionalities. It's pretty much if you're on a data center on premises, you don't want something in the same rack, the same power, the same network top of rack switch. So this is ultimately giving you the option to separate it. You're still in the same data center, but different racks. And I'm going to show you.
Yeah, maybe you can go a little bit back on this one. Like I think you also should cover like if you go to unit 2, like that was the one slide you showed.
Okay.
So we can cover that a little bit in deeper, because I think that is going to be very important, especially if you haven't really done work on the compute side today. Or it also helps to just think about, because Amy is going to show you some stuff about availability sets where there are 2 terms coming up. One is like update domains and one is fault domains. And Amy's going to explain to you exactly what that means. But it's very important to understand, as Amy mentioned, there are different types of things which can cause downtime. And this can be unplanned downtime or unexpected downtime, which you can build basically in the same bucket, more or less. But it's like something when something fails, right? There can be like also in the cloud, things fail. At the end, we're going down to like some physical hosts, right? There are some servers. Microsoft is taking care of these to make sure that they are running smoothly, and that if they fail, we replace them and all that. So that's all great. And by the way, we also have some smart AI features in the cloud in place as well, which learn about errors on the physical hardware. And if they see a pattern of like saying, hey, we have seen that with this physical box, after like all these errors, 2 days later, the server crashed, right? So the AI, the machine learning, uses that information. And if they see another server behaving the same thing, but is not down yet, they can already move virtual machines and workloads which are running on that system away from that server so it can be replaced. So we're trying everything to generate as much uptime, but still there's some errors we can't not foresee, right? And so those are unplanned downtimes comes in. And then obviously you have planned maintenance. I think I'll let you talk about this. We also obviously need to make sure that things are up to date.
Yeah, just like, again, like your on-premises data center, we make sure all of our hosts are up to date, any patching. So we make sure you're not impacted, though. You stay on the healthy physical host, and then while we're patching, and you don't have to. So that's the cool part of the cloud.
Awesome.
But we do not touch the VMs. So just you still have to patch your VMs if you're running IaaS, so.
Oh, that's a good point, Amy. Yeah, that's a very good point. There is usually this graphic of showing the responsibility levels.
Right.
So on-prem, if you do everything by yourself, obviously you're doing all the work on the physical machines. You're repairing the disks. You or not repairing them, but replacing them, I guess. And then you also do the physical work on that. You patch the hypervisor, whatever you're using in your data center. Make sure that that is okay. And then you do like the virtual machine on top of it, and the operating system running in that machine, and the application running in that machine. Now in the cloud, we obviously take care of the hardware, of the physical things, of the hypervisor, and we basically patch these things. But you're, as you just mentioned, like you're still like what's running in the machine, you're still responsible for it. It's not automatically happening. But there are great services like Azure Update Management, for example, or Azure Auto-Manage, which can help you with that. But let's dive in how you can actually prepare for those downtime options.
Right. So we're going to start out with the availability set. We recommend identical set of functionalities. Obviously, if you want like your IaaS or your IaaS server, you want duplicates of it, you'd use an availability set, VMs of similar size, not a database and a front end server. So you want similar functionality that you're just trying to create redundancy for. It's also cool is you can create an availability set with your VM at the time. So I'll show you that shortly. But when you create the VM, you can create a new availability set and then pick your fault domains and up domains, which we'll get into in a bit. And then when you create your second VM, you can select that existing availability set. And that just helps you meet your SLA. It gives you more of that redundancy. Again, you're not relying on one rack for your VM. So I am going to go ahead, and Laurent will kick in my other screen. There we go. So here I'm just going to go create a resource and create a VM. And go to my Learn Live demo resource group. Give it a great name like Learn Live. And then here you see the availability options, and I'm going to pick availability set. And here we go and create new. And you give it a name. Again, I was really creative. Learn Live. I think I put a set. There we go. And what's important here is the fault domains. You can have up to 3. So that means you can have 3 separate power network compute sources. And then the update domains, you can have up to 20. And that is stuff you actually want to update at the same time. So my VM's complete. And I go back in and create another VM and show you that we can put it in the same availability set. Turn my demo 2. Let's pick our availability set. And now I can pick my Learn Live, deploy that. This is definitely sped up. It takes a little bit, not too long though. And then we can go and see into our Learn Live demo resource group. And there's the availability set. And if you click on it, you can see that both VMs are in there. There's 2 update domains. 2 fault domains, 5 update domains. Too many domains here. And they're both running. One's on 1 and 1, and the other's on 0 and 0. So they're on separate fault domains and on separate update domains. But you can change that configuration if they need to be on the same update domain. Again, you want them to be patched around the same time. Okay. And that's it. We can go back to my screen.
Okay. Oh, that's actually awesome. This is really helping us out. So, for example, what you mentioned, it could be like different web servers, like, web servers behind the load balancer, for example, that you don't want to run in the same physical rack. For example, you want to spread that out. Would that also be something like for domain controllers or something like that, I guess?
Right. Yeah, and you wouldn't want them rebooting at the same time with patching. So you'd have them on separate update domains as well. And I have a quick little drawing, not as cool as your whiteboard, but just an example of like different VMs. So your server rack is essentially a fault domain. It's the power, the networking. And so you have up to 3, and then these can be multiple VMs, but they can be on separate update domains, or maybe you want this VM, you're going to duplicate it. Let's say it's the back end. Ooh, come on, copy paste. Oh. But let's say you want it to patch at the same time. So these 2 are going to patch at the same time, but they're on different fault domains. So if this rack goes down, this one will kick in for that server. But they're going to patch at the same time. So update domains means patching cycle. Fault domain means separate power, separate networking. So it gives you more redundancy within a data center. It's not giving you like regional redundancy, which we'll get into later, but at least it gives you more coverage and more uptime for your application. And like you mentioned, you can load balance it like a web server going to each one. So you know, if one happens to go down, your load balancer would detect it and go to the healthy one.
Okay. Yeah, nice. I think there's a very good graphic also in the next page of the Learn module. Sure. I'm not sure if you're done with this, but I think that also is like, because I get this question a lot, is okay, hey, what if I have this 3-tier or 2-tier application, right? So you would create one availability set for all, as you mentioned, and I just want to call that out again. You mentioned that it needs to be the same workloads, not the same workload, basically. It makes not sense to have the SQL servers in the same availability set as well as the IIS web server. If they're doing different things, there's no benefit to it. But you really have like one availability set for all the web servers, and then another availability set for all the SQL, for example. And if you have domain controllers, you would have another availability set for that. If you have some other VMs, in that case, you will also have others than that, I guess. So yeah, that's pretty interesting. Pretty cool.
Okay. We're going to go over availability zones.
Yep.
All right.
So availability zones are actually a very interesting concept. Now, there's a ton of information you can read specifically on this screen, and I will draw a little bit about this. But what the idea is that in Azure, obviously, we have different Azure regions, right? So we have different locations. We have, for example, let's say West Europe, and we have North Europe, and those are is a region pair basically where you can, if you set it up, you can replicate things. Now, however, that always has some implications. Like we don't want to just fail over everything if there's just one issue in one Azure region, right? So let me quickly switch to the whiteboard to explain this a little bit more.
Sure.
Maybe we can share that. Perfect. Thank you.
And it's good to know. Yeah, you have to pick a paired region, right? Like East US is with West US, right?
Yeah. So what a lot of people probably know is if you deploy a workload, you have these regions here. And I call it now region 1, region 2, because depending on where you are in the world, you probably have that. So we have two. In this case, I'm just selecting 2 Azure regions. So
play Hangman too.
Yeah, I need to learn how to write.
Draw a cat.
So, and then we have region N, right? There are multiple regions. I think we have currently over 60 regions worldwide. So we have, again, as we mentioned, Europe, we have Australia, we have some in South Africa, we have a lot in the US, and those are all together. Now, they're far apart. There is a certain amount of distance. These regions need to be away from each other, because in case of a disaster, you don't want the other region to be impacted as well, right? You want to have them as much as possible away. Now, this is great. If you look at the high level of things, right? You just showed how in one building or one data center, you can separate different racks with availability sets. Now, one Azure region necessarily is not just one building, right? One Azure region can coexist with multiple data center buildings. And what we also introduced next to these buildings is different zones. So we split up these buildings. They also have a little bit of distance to each other, and we call them different zones. Every region with zones where zones are available, where availability zones are available, to be precise, has at least 3 zones. That's the minimum of things, but there can be more. But whatever you configure, it's always about these 3 zones. So we have if you look at region 1 here, we have these 3 zones, and these zones are also not necessarily buildings. There can be multiple buildings or data center buildings in one of these regions. However, if they all have separate power supplies, they have separate connectivity things, they're completely separated and isolated from each other. And so if depending on if you're selecting this, you can have I will draw this in red here, a VM running in zone 1 and a VM running in zone 2, and you could even select one in zone 3. And we will make sure that one is running in zone 1 and zone is running in 2 and 3. So that if one of these zones go down for some reason, again, could be power outage, some natural disaster or something, it will not necessarily impact the whole region. So you still have VM 2 and 3 running in this case, which is a pretty good concept. There's also different types of when we look at zones, right? So I spoke now about the example of zonal services, if you will. So where you need to pick and say this VM runs in zone 1, this VM runs in zone 2. What we can also offer is zone redundant services. So for example, if you look at storage, what we can do is we can actually say, okay, well, we have a storage account, and that's replicated across all these zones. So in this case, your data is just in different buildings or different zones available. And so that makes also sure if one zone goes down, your storage is still available. And we have that for a couple of other services as well. So that's pretty cool.
I think SQL database too, right?
Yes, absolutely. Yeah. Yes, you're absolutely right. And so that's an interesting concept of that. And so if you build this out, in many cases where zones are available, we brought the example, for example, with domain controllers. That is also a very good example where you want to put domain controllers in different zones, for example, so that, again, they're protected against if one region goes down. They're not just like one rack goes down, but one building goes down. We will be able to run the server in another building, and we'll make sure that this is up. Now, how do I configure this? I don't want to make a big demo out of this. We're going to show more, I think, later. But I quickly want to just show you it's actually super simple, because I want most of the people out there to use that feature, right? So if you look at these zonal services, like virtual machines, for example, you would go and create a virtual machine. And if you do that in the portal, you can configure like I show you, but obviously that would also work if you use ARM template, Bicep, PowerShell, or the CLI. Now, you would obviously set a name for a virtual machine, and then you would also go in and select the region where this should run in. So that's, for example, let's take Central US for now. And then I have these availability options. So on the availability options, I can either select no infrastructure redundancy required, meaning, okay, we will just place the VM wherever. And if you create a second one, it will also be placed probably in the same rack, maybe. It doesn't have to be, but it could be that it's actually in the same rack. In worst case scenario, even on the same server, right? So if that server fails, both of these VMs go down. Then you showed the virtual machine availability set here, which allows to like go again across different racks, for example. And then the availability zones, as I mentioned, I can now select these 3 zones, right? So when I create a domain controller, the first one, I would probably run in zone 1. The second one, I would run in zone 2, and so on, right? And I can obviously have multiple servers in the same zone. That's fine as well. But definitely you should split it out across these 3 zones. So that's super simple. Now, compare this to, for example, storage, where I say, hey, this is zonal redundant service. There, things are a little bit easier, actually. I don't need to think so much, where do I put this service? I would just create a storage account in this case. Again, would select the region. And then where I can actually select that here is when I go to redundancy. So I have different options here. Local redundant storage, and there's, by the way, a nice description on what this is. It's basically that this is then still protected. There's still some redundancy, but it's more on the server and drive side. So if a server fails or something like that, then that's good. But that's obviously
there's always 3 copies.
Yes,
exactly.
LRS,
yeah, but it's local.
Exactly, but those are all in the same building, if you will. That's one thing there. And so you're still protected against hardware failure, but you're not protected against like whole power outages. We then have the zone redundant storage. That's what I just explained. In this case, we have different zones, again, a minimum of 3 zones across, and they're also like split up, as I just mentioned. So they're far enough from each other that they're not necessarily impacted by a power outage at all at the same time. And so you can use that, and then data gets replicated. Now, this is the interesting part. So every zone, this is like, because also important for networking, we will make sure that every zone in the same region, they will only have less than 2 milliseconds latency between those zones, right? Because we still want to make it fast. It should still work fast and everything, but we're going to give you that extra layer of protection. So this is really, as you can see here, description, data center level failure. And then if you want to go further, this is then geo-redundant storage. And this really is about, data going across different regions. So if you look at where our data center regions are, or Azure regions are, that is really where a whole outage could impact, like the whole country could be impacted for some reason. The other region basically still exists. So that is the different replication mechanism there. So local redundant storage, zone redundant storage, and geo-redundant storage. Now, that said, there's also obviously a cost involved in that. So the less redundancy you have, the less we actually need to store your data, the cheaper it will be, right? So the more you go up in the stack, the more redundancy you will have, but it will be also more expensive. So that I need to mention as well.
All right. So make sure it really needs to be geo-redundant before you make it geo-redundant. Everyone's application is very important.
Yes, absolutely. And if you, I know our producer's not going to hate me because I didn't change the color, because I did not expect to show you that. But if you want to learn more about this, because it's a very important concept, and explaining this for like 10 minutes is probably not enough, right? So we want to go in and to read all about this. There's also some great documentation here, exactly showing how these zones work within a region and when you should use what. So yeah, that's a great example.
That's great. And then up next is, after that, we have scaling.
Yep. Let's move back to your screen, to the module.
Okay. The white, the version.
Yes, nice,
readable version.
Again, apologies to our producer Laurel here.
It was a great that was a great description of regions.
That happens when you're live, right? You sometimes get decisions and you make some choices there. So yeah, let's talk a little bit about vertical and horizontal scaling. I don't know, it's late here. So this is a very important part. And there are multiple ways of, when you look at virtual machines, how you can scale them in different ways, right? Meaning you need probably more power, you need to be more CPU resources, you need to have more memory on different cases, right? So different types of scaling here. So if you scroll a little bit down, you can actually, let's have a look at vertical scaling. And that actually means that we're looking at basically in bigger machines. That's basically what you're looking at. You're making the machine you run your workload on bigger or smaller, right? So
you pick your VM size and then you upgrade your VM size, like a DS2 to a DS4. I don't know if that's really a right size.
No, you're absolutely right. Yes.
Okay.
Yes. So it could be that like you're running a workload, an application, running on a VM, and that just application is used more by more users. Then you probably just go and say, hey, I need more CPUs to handle all that. So we just select the bigger size of that virtual machine. And then if we need less, we can go down. Now, again, this is a great way. And we will talk a bit about the differences in just a bit. But this is a great way. We can see that especially with traditional applications which cannot necessarily be behind a load balancer or something, like really like single, like applications which would run probably only on one server or can only run on one system, right? There you only have the choice to make them bigger or smaller. But if you have more modern applications, if you scroll down,
we can scale out.
Exactly, we can scale out. So that is like what horizontal scaling is like, instead of making the VMs bigger, we can just add more VMs running the same application. Like the perfect example you brought before with web servers, for example. If you have a website which is always like can be the same, right? I can just add multiple servers there, and then I can like run a load balancer in front of it, and all the traffic will be aligned. And so when I know I need more traffic, or I get more traffic on these web servers, I can go out and scale out and say, hey, it will create me more of these machines. And then the load balancer will handle that. And as soon as I need less, it will scale down again, or scale in. That's the right word, because scale down is the other one. Scale in, and then you obviously save costs with that, right? The less virtual machines you need to run, the more costs you're saving, right? So that's what and this is also a good example of the power of the cloud, right? Because you're not buying, like if you do the same thing on-prem, you need to buy the whole thing.
Be running and racking.
Right?
It's not fast. I don't like racking servers anymore. I'm kind of
exactly. And the cost of it is that you're buying the biggest thing. I worked with a customer, they do printing, like T-shirts and books and things like that. And they, in the past, like before they started to use cloud computing, what they did is like they're like 80% of their business they do like in November, December, before Christmas, right? That's when everyone goes out and prints like pictures of their dogs and things like that on the T-shirts.
Or cats.
Exactly. you bring this up, and that's when they need all the resources they can have, right? That's where, yep, good example there. I can see of the cats, yeah. And then that's where they need all the resources. But the rest of the year, the whole thing is they probably don't need, like they probably need 20% of that capacity, if not less. And so what they need to buy the whole thing. And that's what it. Now with cloud computing, this is the beauty of it, is with that dynamic scaling possibilities, I can just go in November, I can turn it up and say, hey, I need more power, I need more resources. And then when Christmas is over, I just scale it down again to whatever I need. And same thing if, for example, if you think about ticketing companies, where if they have a new Taylor Swift concert,
they definitely did not scale in time for that.
Then you would go out, if you start selling these tickets, you would scale up, right? Or scale out your workloads, and then scale in again when things are done. So there's some pretty good example of this. And if you scroll a little bit more down, there are obviously some considerations and limitations. From my perspective, as I mentioned, there's some applications which cannot necessarily be like split up, like behind the load balancer or whatever it is. It doesn't necessarily be just behind the load balancer, but it's really just one application, one running in one system, running on one server. That is something where you really need to have vertical scaling, right? Where that's your only choice.
Right. And you can do it on a schedule. Like you said, a sale's coming and it's tomorrow at 8 a.m. So you can scale beforehand, or you can do like a CPU memory utilization, and then, scale when this happens, and then scale in when it decreases, or scale in on this date. So that's kind of nice too.
Yep. I think that's also what we're gonna look at in just a bit, is like, hey, how can we take the advantage of this? And again, like horizontal scaling is really a beautiful thing if the application and the workload inside allows it. I'm a big fan of that, because in addition to not just having that more performance and more load, you can also have obviously some redundancy with this as well. If I have 16 virtual machines behind the load balancer, if one of them fails, I have a little bit less performance until we start it up again. But if I only have one server doing the work and that one crashes, the application obviously is offline.
Right. Definitely.
So Amy, do you want to show people how to actually implement some solutions that we have some very interesting ones in Azure there?
Yeah. So like you mentioned, we do support the use of an Azure load balancer for layer 4 traffic. And you want that same base operating system, obviously, because you're going to create a virtual machine, and then it's pretty much a duplicate. And
okay. So that's what virtual machine scale sets are. I think
yes. Sorry. Yeah, I'm jumping the gun there. So yeah, with virtual machine scale sets, not scaling out, but now virtual machine scale sets, you have an application and you want a scale set to support it. You can create one and create copies, and then scale out again based on like CPU or a schedule, and then scale in. But we support up to 1,000 virtual machine instances, and then the limit is 600 if you create your own custom virtual image. Okay, so creating one is pretty simple. I am here in the Azure portal, if you can see my screen, and under basics, you just give the virtual I'm sorry, but you go to home and then you type in virtual machine scale set, and it'll come to this screen. And then you select your resource group, you get the scale set a name, and you pick your region. And you can do uniform. So that's optimized for large scale, stateless workloads, identical, kind of what I mentioned before, or more of a flexible model where it's high availability at scale with different virtual machine types.
Okay.
And then you pick your image. There's also, I can't get rid of it, Spot. So that's a way to save money. So if you know it's going to run at night and you can go on with Spot instances, then it'll grab the cheapest thing and run it on the Spot. Just a great way to scale out with less money involved. And then if you go to advanced, this is where you pick your spreading algorithm, your max spreading or fixed spreading. The default is max. fixed isn't really recommended, especially if you're using zones. And yeah, you can even pick proximity placement groups, kind of like those group placement settings if you want them close together in the same region so they can talk faster to each other. But that's pretty much.
Oh, okay. That's also interesting. So we were now always talking about splitting VMs up, and that they are not as close as far away as possible from each other.
Right.
But obviously, sometimes applications also need to talk with each other, and then it makes sense that they're as close as possible to have the little latency as possible. And that is what proximity places groups are for.
Right. You're not going through that router. You can talk layer 2 and get faster connectivity.
Nice.
And then,
okay,
what was it? Oh, scaling here. So yeah, you can start with your 2. Obviously, you want to start with 2 more than 1. And then this is where you can do the manual scaling.
Yeah.
And give it a default policy, balance across your availability zones. Or if you go auto scaling, you can give it a minimum number and a max. Like I only want to get up to 10 after that. And then you can scale it based on CPU metrics. Like when I hit 75% for 10 minutes, give me another VM. And then scale it back in when the CPU starts dropping and decrease by 1. I haven't played with the predictive. That's pretty cool. It sounds like your predictive AI stuff.
Yeah, that's the beauty of like when AI comes together, right?
Yeah.
It's like the same thing as I just mentioned with being predictive about hardware failures, for example. We can obviously also try to have that, use machine learning and AI to predictive, like see workloads running, right? Like, okay, we know when this behavior happens, we don't necessarily know why it happens, but we know that when this behavior happens, we can actually go and start the scaling process for that. So that is usually a good thing. To be honest, again, this is a preview feature, but I would, like, if I would work with virtual machine scale sets, and I use auto scaling, which is I think we can talk about in just a little bit more as well.
Yeah.
But then I would definitely enable this. Again, it's now in preview, so it's not a production supported feature right now, as usually preview says. But actually, that would make sense, right? Because I know that, like, in some cases, so like usually what we do, let's scroll up. If you can scroll up a little bit,
Sure.
In this, when we talk about auto scaling, like what you can configure there is a couple of different things. So you obviously have you have the initial count of instance, like that's the top. Like, okay, we're gonna do 2 virtual machines in that scale set. And that's a good thing because then you also get the redundancy, right? Then, as you said, there's manual scaling where you can basically pull it up and down, and depending on you need to react. But then with auto scaling, you first define what's the minimum of instances you want to have. Now, I personally probably would set it as 2 because if I don't want to have just one virtual machine running, right? I still want to have it, right? So I would always select, but that's my personal preference. It really depends on your situation. I would set it as 2, and then they have the maximum instances. Now, this is also important for cost budget reasons, right? Because I'm not sure if you said like 1,000 virtual machines.
Set up to 1,000 if you're using RVM, right?
So if there's like something happen and you have like ton of access, and it's great, you want to keep it running, right? That's good. But then if you set it to 1,000, you can obviously also set up 1,000 instances equals 1,000 of these VMs equals thousands of the amount of money you need to pay for these VMs, right?
Equals your phone ringing from the CEO.
Exactly. So, it will be like, okay, at the end of the month, you get the bill for
the bill.
Like someone is asking, right? But that's a fair point. And in some cases, if you think about like you're a large retailer, you probably want to go up to 1,000, and you want to have like every single sale. But if you're a smaller company, you want to probably think about this in a way that, okay, how much do I actually need at the limit, and where do you go? I mean, you should still go later on and increase that number, right? If you're seeing it, there's more demand, but you can limit it where how many instances you have.
Yeah, max of 10. I don't care if that last one's at 80% CPU. Just let it be.
Yeah. Now, if we can have that screen again,
sure.
then we can kind of have a look on like how does now the automatic part actually work, right?
Mhm.
So if you scroll out a little bit, there is the scale out part, and that is also why
Yeah.
we talk about scale, horizontal scaling, for example.
Mhm.
Now, what we give here is a CPU threshold for a certain specific amount of time. What should happen, right? So if the CPU threshold of these VMs, of these instances, is 75% for the duration of 10 minutes, we will add another VM to it. Now, that's great, right? So if then the CPU count goes down, that's a good thing, and we go on. But if the CPU amount is still high, we will add another instance, another instance,
Right.
another instance. Again, depending on the maximum number you set. And this is like, you can see here the scaling mode is now based on CPU metrics. There's also one then on scheduling purposes. Perfect. Where you can say, if you already know that like most of the access is going to be every Monday or every Tuesday or whatever.
Taylor Swift sale. I mean,
exactly. or you know that like, hey, most of my shopping happens during the day, and I don't have so many people like accessing my shop or my website during the night. Then you can also scale it down through that. So it's kind of like also a manual thing, if you will. It's like a scheduled thing, but it's still pretty not really reacting on the demand.
Yeah, so, more proactive, because you're assuming you're going to be busy on, let's say, Monday, so you're going to say it's valid all day Monday.
Yeah. You've got to be kind of like proactive and pulling it down, and it can be good. Could be a good thing, right? It can absolutely make sense. If you select again CPU metrics, there's also another important part to this. I mean, when you schedule it, you would say, okay, only during that time period we're scaling up, and during that after that we're scaling down again. Now, by CPU metrics, you obviously have to scale out. Like in this code, that's the threshold, but you also want to scale in a little bit again, right, to make sure you have less instances, and that's where you also can configure, okay, if the CPU threshold goes down, you can then remove instances again. And so that is, again, this is all pretty cool. Now, one problem with that, obviously, if the CPU threshold is at 75% for 10 minutes, in these 10 minutes, I'm not sure how good your application performance will be, right? Because you're using 75% of that instance. So there's some downside to it with the reaction time. Right. So you already have a lot of load, and then we say, okay, we're going to add more capacity. So that's when the smart thing about the scheduling comes in place, where you say, well, I know already that's going to happen, so I'm going to do that. But then you have some other downsides again with scheduling. You don't know what if happens suddenly, like you have, I don't know, a crazy amount of people shopping at night now, and then what would happen then, right? So this is where I say this preview feature we just had in the portal, where we use some machine learning and the AI to learn, can be super helpful to predict what is going to happen. So we don't need to wait until the CPU load is at 75%. We can already like predict what's going to happen. So we can already add an instance before it even goes that far, right? So there's some smart things you can do when it comes to scale sets and auto scaling and so on.
Yeah, that'll be neat when it can actually predict. And normally when this starts happening, I need to scale out and then don't have any impact to your application.
Yep.
And I also wanted to highlight quick the scale in policy. The default is it's good. It just deletes the VM with the highest instance ID, but everything stays balanced. But you can decide to delete your newest VM or delete the oldest created VM as well.
Okay.
If there's preference.
Okay.
So there we go.
So
there's the options for scaling in. The default is just balance across, delete the VM with the highest instance. Otherwise, you can go, hey, that latest VM I created, just delete that one, scale it in, or the oldest one that's been running in your scale set.
Yeah. That's actually a very interesting thing as well. Obviously, there's a lot of thinking in that. Now, what we also should cover, and I know that you mentioned like before that there are different options, like these VMs, when we have this scaling thing, it's obviously not something where we create a VM and then we RDP or SSH into it and then go manually configure, right? there must be like some sort of automation we need to build around this, that we can actually take advantage of auto scaling and or scaling in general. That we don't want to just have someone like an admin going in and configuring these 1,000 VMs and then like deleting them again. And so there needs to be some automation. Do you know, like there is, you mentioned there is 1,000 for normal images, I think, and then there's
Yes.
like 600 for custom images or something like that.
This one. Yep.
Okay.
Custom 600. Yeah.
So if I have an application which requires some sort of special configuration on the operating system and installation, I could create a custom image and do that and configure that. So this is a very important approach for people who dealt mostly, I guess, with on-premises VMs, where you would go in, you create the VM, and then you go into the VM and you configure it, and you do a lot of things, steps by hand. In this case, if you're going in that direction, you don't really can do much by hand anymore. You need to build the automation around it, right? You need to have like scripts in place, like
scripts running.
Probably do some infrastructure as code there, use some extensions, script extensions to configure what happens if a new instance is created. So yeah, that's also an important part there.
Yeah, it's a great point, because then this module has a lab, and it does have you run some PowerShell scripts and edit for VM extensions. So you can run the PowerShell scripts, so you can automate like even creating the IIS instance on the VM, so you don't have to log in, get IIS up and running. So
okay,
it's a cool module. So this is what we already went over, the orchestration.
Yeah. So this is also, by the way, there's some interesting reads here. We can point these out quickly, these bullet points here. When you configure VM, there is a ton of different stuff to choose from, right?
Yeah.
So
image, yeah.
You talked about, when it comes to scale sets, it makes a lot. You talked about the orchestration mode, right? So that makes a lot of sense to look at that, how that works. If it's a stateless application, or if it needs to be some more on the high availability side. The other parts are already pretty like straightforward, but still important. Is like, okay, what image do I use? So in this case, the screenshot, it just shows us a standard image from the Azure Marketplace. But obviously you could, as I mentioned there, like as we talked about it, have like your own images as well, not just the Marketplace images, which is great. And then this is also, I think, very exciting. Again, has nothing necessarily to do with like availability, but that you can now not just choose the x64 architecture, but also ARM64, which is pretty cool. So in terms of power consumption and so on, there are different options, and some applications which are now specifically built for the ARM architecture can take advantage of that as well.
That's a good point.
And then, yeah, go ahead.
Oh, the spot discount I think is great, because you get the discounted rate. It's kind of like the clearance bin of VMs. You pick your spot discount. Run this VM when it's this much money. Okay, cool. So that's a good way to save money when scaling out.
Yeah. So there's by the way a ton. Like I am happy to do, like we're talking about spot instances. I think that's a great way of saving money, because and especially also because a lot of people don't know about it. There's some other stuff which also helps save money on IaaS VMs, right? Like such as reserved instances and things like that, which you can configure as well to make sure that if you, for example, know that your VM runs for a year 24/7, you don't need to pay for the on-demand price. You will just pay for like a fixed price for a year, and that's obviously cheaper than that. However, then you lose the availability of like scaling and scaling up and scaling down, for example. So there's like different considerations you need to make there.
Right. Okay, so implementing Autoscale.
Yeah. So this is what we also just talked about, right?
Yeah. So things to consider: the adjusted capacity for positive customer experience. Consider scaling out, like you mentioned, because scaling up is definitely harder.
Yeah.
and then
Yeah,
control
exactly. So
scheduling.
one thing I need to mention, by the way, our scaling out part, I think we haven't really talked about that, but
Mhm.
it always showed like add one instance, right? But if
Right.
you know that, hey, one instance probably just be a drop on the hot stone, you could also go and say, hey, just add directly add 2 or 3 instances
Mhm.
at the same time, because we're probably going to need that so that it normalizes more quickly. And the great thing is, like I was working with a customer where we discussed this, is like, hey, there might be a good thing of scaling out quickly, like have these
Mhm.
machines there, but then slowly scale in again to like say, okay, then
Right.
we're going to take one after one down, because we don't want to risk to running the same thing and then need to add again 3 machines.
Right.
So
Mm.
there's different values you can think about and make it work for you forever you have. Right?
Well, yeah, I guess if you lower that CPU threshold to like 50% and it's going to scale out, and you keep the scaling in like super low. So you're not scaling in until it's like the VM's basically not serving anyone. So that's a good
Yep.
way.
Perfect.
And so the auto scale option, yeah, I went over it in here, but it's pretty much what we went over here is the auto scaling again, minimum, maximum, CPU or schedule. So we kind of jumped ahead of the and then yeah, you can even apply a force delete to scale in if you're really like, just shut it down. You can make it delete versus scaling it
So,
in.
yeah. So one thing, I just got a question there
Yeah.
from YouTube. What if this predicted, that was when we talked about the predicted workload,
Hmm.
or in general, like what if the predicted workload will not come? Who will pay for the resources built necessarily? So, because at the end, I mean, this feature we can just help you with and it's predicted, right? But like you
Hmm.
obviously pay what's going to deploy. So the customer will pay for what's deployed. So you need to obviously trust that feature or trust what you built, or you don't enable that one, right? But it will not be that, at least for now. Again, this is a preview feature. I don't want to talk about the team, like they should talk about it, how they're going to handle it. But my assumption is, okay, well, the resources are there. Someone needs to pay for it.
Right.
It will not be like for free, just like, because otherwise it would be a great feature, right? And who at the end would then decide, did the workload come or not? So, but yeah, if you want to like have the exact details, we can definitely like check out if we can have your question and talk with the team who builds that feature specifically, and to figure out what's going on there. But my assumption there is highly that at the end, if there are resources deployed, that will be the customer who will pay for it.
Right. And hence why it's in preview and not GA too. Maybe there's better ways.
So
um,
you want to talk about the lab a little bit in this?
yeah, we'll talk about the lab and then go over the knowledge check. But yeah,
Perfect.
I thought it was a nice surprise because there's an interactive lab simulation, which is really cool. It kind of goes above and beyond just virtual machine scale sets, and because you use custom script extensions and you run a PowerShell script to expand a data disk and then um, change VM sizes, and then you update your scale set to be the bigger VM size. So it's a really interesting module. It takes about 40 minutes, but it's click through, and then the lab scripts are even available on GitHub. So you just click here and it'll start talking to you. Click here. But it's a great walkthrough.
Yeah.
Um,
Yeah, I love what, like, it's really going like everything we just talked about. Obviously, we touched it more on a high conceptual level, right?
mhm,
Where we were like, okay, this is why you would do it, this is how it's done.
right.
But obviously, you then also need to the exact detailed step. Like as I mentioned, one of the examples here is if I use virtual machine scale sets and I use this automation deployment model, like how do I then configure the VM that the application
Right.
works and is there, right? And I think that
Mhm,
is like there's an example in this lab which you can go through, and you can then leverage that exactly to build your custom configuration.
right.
So that's good.
Yeah.
So
I
shall
have
we
a
go
great.
to the knowledge check?
Yes, without giving away anything. Let me. Okay, now let's check. I'll go there. Current slide. All right.
So this is something we're gonna do together.
Yes.
With the audience. So you have the chance to actually be part of the knowledge check, right?
Yes.
So
You win prizes and actually not. You win knowledge.
yeah. So go
Yeah.
to aka.ms/polls. That's where you can vote in terms of our different questions. We will just put them on the screen. We will go to question 1 in just a bit.
Yeah, so it's a 3-part question. So I can read it out, but you're welcome to read along. So you have an organization with diverse requirements for configuration and availability of their virtual machines. So you have your admin team. They're testing an implementation of Azure Virtual Machine scale sets with 5 VMs. During testing, monitoring alerts show all VMs running at maximum capacity. However, you discover that when the CPU is fully consumed, more VMs aren't deploying at scale. So we have to figure out why aren't they deploying. Second scenario, the DevOps team wants to configure Azure Virtual Machine scale sets for their production servers. Thursday evening is typically the busiest time in preparation for delivery to customers by end of business on Friday or close of business on Friday. Conversely, early Monday is generally the quietest time. So you need a plan to add more machines when that workload is high. And then lastly, we have a scenario where load increases on applications hosted in a scale set, but you want to increase the CPU capacity of the existing instances rather than deploying more. So we kind of went over all those scenarios in the portal. Let's see if we can get the right answers to these scenarios here.
Let's go to question number 1.
All right.
Question number 1, how can you ensure more virtual machines are deployed for the admin team when the CPU is 75% consumed? So there are 3 different options you have, and you can vote right now on aka.ms/polls. A, manually increase the instance count. B, change the CPU percentage to 50%. Or C, enable the autoscale options. So there's like that. We want to give some time, obviously, after each question, because we also have some delay.
See the votes coming in.
Yeah. So please start voting, and we see kind of the first votes here.
I mean, technically, you could manually increase, but that wouldn't be fun. I mean,
yeah, I would think the same. When I read like I mean, if you have an admin watching 24/7,
right.
you have like, okay, it's heading 75%. Okay, I'm gonna manually check.
Right. If you have a knock,
monitor and then alert, and then someone does manually change. However, that's obviously not the most elegant way. So I would not think that this is probably the right answer.
I'm gonna go with C, enabling autoscale. What do you think, Thomas?
I think you will be right, and I think also our voters are heavily, our viewers are heavily trending towards
that is
C
the majority.
as
well. Right. So let's hope we're right.
So let's see if that's the right.
We go down together. Let's see. Go on. Come on, PowerPoint. React. There we go.
Yeah,
Yay!
we go.
There should be like little fireworks, I think.
You got it right. We should have some applause here. Both got it right here. So yeah. And also, again, most of our voters got it right as well. Yeah. So let's go to question number 2. And again, everyone in the chat, everyone following this video, everyone can now go, video, I should say stream, because obviously we are live. You can go to aka.ms/polls. If you haven't done that, let's have a look at question number 2.
Okay. So like DevOps team, they know it's going to be busy on a certain night and quiet on Monday.
Yeah. So that's actually, for me, it sounds pretty good. There are like 3 different options. I feel like if you have the times in your mind, it's probably pretty simple. So let's say there is A, schedule-based rules. So you can, like as we showed, you can have like time-based rules. Amy did show you on the screen. You can plan it. B, autoscale, which we just also talked about. And C, metric-based rules. Right. So again, let's let people vote here. But I have certain tendencies. I mean, it sounds like they know what time it is. So
it sounds like nobody works on Monday apparently because it's quiet. So
Exactly. So yeah, we also see our voters. Our voters, they
Yeah.
definitely like A as an
A. So
answer.
let's see. Schedule-based rules. Yay! Schedule-based
Yes,
rules.
well done, well done, well done, everyone. Like everyone voted for A, so that was pretty
Yeah,
clear. Great job,
that's great.
everyone. So let's do number
Alright.
3 and the last question of this module.
Yeah. So what type of scaling can you use to increase the CPU capacity for your existing virtual machine scale set instances? So we got that horizontal scaling, vertical scaling, or load balancing.
Okay, so there is definitely some interesting things. We talked about that quite extensively. That there's like horizontal or vertical scaling. And because I talked about it, I'm pretty sure I got it right. But yeah, let's see. Also from the viewer side, I feel like we have the
Let's
live
see.
results here.
Yeah, let's see. I'm
So
gonna check the polls.
they seem to be going in the right way as well. So
Yep.
what
Because
should
it's
we think?
existing. I think the keyword is existing. That you're scaling existing sets.
Increase
So-
the CPU capacity, right?
Right.
So in a way that, okay, of the existing virtual machine scale set instances. So
Right.
each instance gets more CPU, and that is obviously vertical scaling. So
Good job, Thomas.
thank you. So yeah, also our voters again, like everyone, kudos to everyone. Not a single vote was wrong here in this question again. So well done, everyone.
Right.
Again for voting here.
If there's any
really
questions, throw them out too.
Yep.
But we do a good summary.
Yep.
We implemented availability sets and zones. We implemented the update and fault domains with the beautiful drawings from Thomas on the zones. Using Azure Virtual Machines scale sets. And again, if you do that demo, it really does a nice deep dive into it. And then auto scaling your virtual machines.
Yeah, I feel like there's some pretty good stuff in this. Again, also when you learn for the AC 104 exam. Also, if you're not learning for a specific exam, if you're dealing with VMs on Azure, this, to be honest, knowing what we just showed, I really feel is a must. Like this is
Right.
if you are responsible of deploying and managing VMs, you should know about these things. Like even if you're not necessarily using all of these, you should know about them because some of them you should definitely use, right? Like depends on what you're building, but yeah.
Unless you want to get a phone call or why is this? This is slow. I can't buy my T-shirt from Tom. Tim Tams and cats on it.
Yeah. So there's more resources available. If you want to learn more, people can check this out. And we also have the link here to the actual AC 104 exam, which is great if you are an Azure administrator and you want to show your skills and like get certified on managing Azure infrastructure and doing administrator work there. That's definitely a great exam to do. I always recommend this, by the way, to everyone. It's just also learning about the fundamental services in Azure and how the fundamental things in Azure. Now there's also an AC 900 exam, which is basically the basic, real basic Azure fundamentals exam. But I feel like if you're more on a tech person, if you're, for example, like really following this live stream, you probably are. You really want to know how scale sets work, how scaling works in general, how regions are defined, how zoning is working, how can I get more availability, then I think that's a really good exam to do and learn for. There's a lot of more than just this, right? There's also networking, security parts in it, recovery, and disaster recovery. So definitely good stuff there.
Yeah, all on the Learn modules, and you can enough to get your AZ 104.
Yeah. So for those who are probably just in the stream but haven't really went to the Learn module itself, this here is the place where you can go and do the specific Learn module by yourself now, right? So you can go out and now you don't have Thomas annoyingly talk to every single step. You can really go through and do it in your quiet time. And again, as Amy pointed out, the lab there is absolutely great example on learning what we just showed, right? Like really going through all the details, making sure that okay, you understand how it's configured.
Right. And like I mentioned too, the scripts I noticed were on GitHub. So if you actually wanted to do it in your environment, you could absolutely create the VM, like model the demo and create a VM, then you duplicate it, you run the ARM template, and go from there and just steal the PowerShell scripts.
Yep, absolutely.
So, yeah. Great. And I think, don't forget, and next in the series is optimizing performance and cost by using Azure Disk Storage, April 20th. And you can continue your learning with this next module in your series. So don't miss out. There's the QR codes and it's all part of the IaaS Study Hall series, infrastructure as a service. So that's why it's VM based, storage based, stuff like that. And it'll be episode 18. But thanks for joining us, and definitely keep following along in the series to keep learning.